Hey guys, my name is Aditya. I'm on Datadog's APM team. I'm an engineer there. It's been great talking to everyone so far and getting to finally put faces to names in GitHub avatars. Yeah, I'm excited to tell you about the tool we've built and sort of give you a sense of how it coheres with the Datadog infrastructure product that you know already and hopefully enjoy using. And I'll try to tease out what we mean by full stack observability. I want to show you 3 monitors we have defined in Datadog's own Datadog account that we use to monitor ourselves. So there's a bit going on in this slide, but bear with me for a second. So these 3 monitors are meant to catch sort of like failure modes in 3 different layers of our offering. The first one right at the top is a monitor we sort of like came up with, like had to put together the hard way after realizing that we had too many dead tuples in one of our Postgres tables that was greatly slowing down some of our select queries and table scans and had an adverse effect on various components in our sort of like metrics and alerting pipeline. The second monitor is on one of our Kafka consumers. So we use a highly replicated Kafka queue to essentially like store your time series metrics, and we have consumers on the other side of that queue that are working hard to like make those metrics available for queries. This particular monitor, second from the top, is meant to sort of catch sort of lags in that kind of processing. And the third one right at the bottom is arguably the most critical of these because it's pointing out an actual sort of like user-facing error, right? Like there's a high incidence of errors in dashboard endpoints and people are having trouble sort of seeing their dashboards refresh. So a couple of interesting things about these monitors, they all sort of need to exist and are necessary because each of these components can fail independently and in sort of subtle ways, and it requires a human to like be there to respond and actually be able to analyze what the impact of one of these failure conditions is. And the other interesting thing about it is that all of these monitors can trigger and sort of result in the same end state, the same end symptom for the user, which is missing recent data on graphs. And this is obviously sort of an emergency situation for Datadog that we care a lot about, and we sort of generally need a responder on hand to analyze what might be going on behind this query and actually figure out what the components are responsible for this degraded service. So if I could ask you guys to like put yourself in the headspace of a similar user-facing emergency in one of your sort of like production services, and sort of think through how you would go about actually getting to the bottom of what the components responsible for this kind of heavy failure are. And this is sort of the kind of tool that we built the Datadog APM offering for, because we wanted to sort of plug into your existing monitoring tools and give you sort of a full stack of visibility to actually understand what's going on here. So this particular, the endpoint that actually serves a graph like this one is the series batch query endpoint. That's what it looks like when it's working well. While it may be doing a relatively simple thing on the surface and taking a graph definition and spitting back a time series into a graph like this, it's actually talking to a bunch of disparate services in Python and Go. It's talking to some more sort of like traditional data stores like Postgres and Redis, in addition to some homegrown data stores of our own. And it's involving itself in a number of different subtasks that each represent a point of failure or a point where something unexpected could happen. And in order to actually like intuit what happened during the course of a single request or a single sort of error state, it's actually like surprisingly hard to do, given that these are disparate systems and the communication between them like can have sort of like various adverse failure modes. And so maybe this is a sort of maybe this is a situation that resonates with you, where your app has a number of moving parts, is consistently changing and evolving. This sort of like recalls one of Alexi's slides from the first presentation of the day, where we have all this complexity to deal with, and we have services being phased in, old services being phased out. We have expertise being handed off from one team to another, and we consistently have to ask ourselves these questions of why is our app slow? Why is it broken? Or worse still, why is it slow or broken for another user sitting on another continent? And all of this together is sort of, these are the sort of questions our APM tool tries to answer. And the tool of choice we have chosen to actually like expose this information to you is tracing, distributed tracing to be exact. So what do I mean by tracing? So tracing in this context is a specialized form of logging. I like to think about it as adding another axis to like the traditional log file where you're sort of like tailing a process and like observing it evolve over time. Tracing is that, but like blown out to like several different processes in several different environments and crossing host boundaries and service boundaries such that you can follow a request as it jumps from service to databases to caches, et cetera, et cetera. And in effect, it sort of makes a complex system that has several moving parts into a more legible, grokkable whole that you can understand and figure out in a reasonable way at a reasonable time frame. And so what sort of the end state of distributed tracing is we actually get to see our batch query endpoint, which is serving data into your dashboards, into your monitor status widgets. We actually get to see exactly where it's spending its time. And I'm going to show you a more interactive version of this in a second. But in effect, sort of like the flame graph view you're seeing here is you have time on the x-axis, and you actually see each of these sort of chunks represents a chunk of computation time. And so you know, like, hey, this amount of time is spent making queries to our replica database. This amount of time is spent in one of our sort of custom microservices, and so on and so forth. And if I could jump into a quick demo where I can actually walk you through how this actually looks in terms of a running live traced production environment. First of all, I'm going to walk you through, talk about how we actually get this data into your systems. And so we have open source clients in Python, Ruby, and Go that integrate with your application in a very sort of like non-intrusive way. The idea is to essentially be sort of like a good citizen in your application environment. So for Ruby, you would just drop in a gem to your gem file, and then we sort of like ensure that any sort of request coming into your Rails application, for example, or a request that you're making via Rails, via active record to your ORM is appropriately traced. And similarly for Flask, we have a similar way for you to like attach our middleware and actually start streaming data into Datadog for every single transaction that comes through your infrastructure. And now, time for a quick demo. So what you're seeing here is Datadog staging infrastructure, sort of broken out into individual services. Our tracing clients will do the job of actually like splitting up your application into its component web, database, and sort of cache layers. And we do this deliberately because it sort of makes a lot of sense to us to be able to view health metrics for these disparate services in their own little like self-contained views and self-contained dashboards. Splitting up your application between web and database like this also makes it possible to do a kind of like bottom-up analysis in addition to top-down analysis. And I'm going to talk a bit more about what exactly that means. And so what you're seeing here is a mix of various services that we have in Datadog's own infrastructure. Some of them come from like out-of-the-box integrations that we have. Some of them come from sort of custom tracing, which our clients expose an API for you to plug into. And in general, we encourage you to like split up your services based on the business case or the business domain that they're operating in. So you can actually see like, hey, this service that's used for authentication has an error rate of X, and you can sort of like comprehend your SLAs in a more reasonable way that way. So if I were to jump into a single one of these, so what you're looking at is a pool of Pylon's web servers, and I'm just going to jump into a single one of these web servers. And so what you're looking at here is actually it's sort of a high-level overview, a dashboard of some key health metrics for your application. And this dashboard is available to you out of the box. Sort of the moment you plug in our tracing client, we expose these health metrics to you to give you a good sense of where exactly your application is spending time and what the key metrics you should care about are. So we have, going clockwise from the top, we have sort of total hits, which is basically like requests coming into your application. We have percentile latencies all the way up to P99 and max. And so we allow you to understand the full spectrum of requests coming into your application and what sort of the long tail of requests looks like. We have error counts, which is obviously important to be able to track how many sort of 500s you're serving via web app. And this is probably what I think is one of the more useful graphs in this page. It's a representation of time spent by the server in terms of its downstream components. And so what we've done here is actually split up this web server this web service, McNulty Query, into the various downstream components it relies on. So there's like a Redis database, a Cassandra database, a couple of Postgres hosts as well. And we can actually see over time the evolution of how much time is spent in these downstream dependencies. And so if you deploy a change that makes your cache ratios a little bit better, you're generally going to see this evolve over time as you sort of track the use of your caching layer versus your database layer in code. And this makes it a really useful way to sort of like catch these issues and catch these regressions. In addition, we have these exact same metrics scoped to your individual endpoints as well. And so we can actually see each of these entries in the list is one of our sort of like handler functions in our web server. And so for Rails, you'd sort of see your like Rails controller and the method being executed on it, similar for like Django and Flask and other web apps. And so if I were to jump into an individual one of these endpoints, these handler functions, I can see, just gonna refresh that really quick. Cool, so now I see these exact same metrics scoped to individual endpoints. And this is super useful because it actually allows you to like drill into sort of like problematic endpoints. Like if you have a user or a set of users complaining about latency in a specific subset of your routes, you could actually give you the tools via Datadog APM to like jump just to that subset and be able to understand things and scope your view in a way that's meaningful to you. And so what we actually have captured here is a bunch of several transaction traces. And I showed you a brief glimpse of this earlier, but in essence, we're consistently capturing a statistically significant group of transactions from your live running applications. And so the idea here is that we want to give you visibility into what the entire spectrum of your application performance looks like. So we're not just going to show you like the slowest trace, or we're not just going to show you like the one error trace that happens. We want to show you a view of like how your application behaves in various different scenarios, like in a hot cache scenario or in a cold cache scenario, for example. And that is super useful to developers and operators as well, as they try to understand how their application behaves under particular instances of infrastructure pressure, for example. So this view can also be scoped a little bit further. And so what we have here is a distribution of requests into certain time buckets. And so we can sort of intuit where like our P99 lies as far as what our slowest requests look like. So I can jump into just a certain subsection of requests and actually say, hey, okay, so these are things that are P75 and higher. So I can jump into an individual one of these and be like, hey, this took more than a second, and I can actually look at exactly the servers that were responsible for the services, rather, that were responsible for that additional slowness. So now I'm going to jump into an individual one of these traces. So an interesting thing about our traces is they sort of like marry the traditional out-of-the-box integrations that you get via Datadog APM with sort of with custom tracing as well. So you can use our tracing clients to like wrap a problematic function or like wrap a problematic bit of code that you suspect to be a bottleneck. And so everything you see in green here is actually one of our custom traced expressions. And you can see we give you the tools to actually like decorate your transaction traces with rich metadata, so you can actually see exactly what the state of the world was when this request got executed. And we encourage you to put as much metadata onto your spans and onto your traces as you consider useful, just because it gives you all the visibility you need in a single place as to like how this particular request performed and why it might have done something that you did not expect it to. Another interesting thing about this particular trace is that it's actually spanning a bunch of hosts as well. And so you can actually see it jump across host boundaries over here. So Royce is a service that sort of functions as a caching layer for some of our more recent metrics data. And we communicate with it over gRPC via our Python web application. And so we've been able to tie into this particular framework to say, to actually understand that a gRPC request that crosses a host boundary is part of this same unified transaction. And being able to sort of propagate your context in this way across a distributed environment is sort of key to like constructing a full map of what your transaction looks like and what and sort of what the various hosts and the various services that it touched are. Another key thing to note is that all these traces are host aware. And so you can consistently jump back to the actual host or process that executed this transaction and sort of identify spots where you have hotspots in a load balance pool, for example, or if you have one host misbehaving when it should be behaving exactly like every other host is. And so this sort of general level of detail is super useful to you when you're sort of targeting the end user problem that I mentioned right at the start. When you know that users are experiencing heightened slowness or heightened latency or heightened error rates, and you want to sort of like tease out exactly what subservice or what downstream component is responsible for that. We're also consistently capturing error traces as well. And so I thought this trace was interesting because it points out one of the failure modes for this batch query endpoint. So we had one of our Redis servers that we communicate with over the Redis protocol went offline briefly, and it sort of like exposed this this strange failure mode for our batch query endpoint, where we didn't really have sort of like a graceful failover for this particular case of a downstream server going offline. And so these are the sort of general failure modes that we look to expose via APM, and we give you the tools to sort of propagate error tracebacks up the stack and make sure that once you surface a transaction in the UI, and if it was a 500 error, for example, that you have mostly all the context you need to actually identify where that error came from. And another thing to note is that all these metrics tie directly into your existing dashboards as well. They can be, you can throw them on a dashboard, you can throw them into a monitor. I'm just going to show you this sort of new latest feature we enabled. But yeah, you always have the option of alerting on these metrics as well. And because we're sort of collecting them for you out of the box, we give you some interesting tools to actually say like, hey, this is the sort of standard rate of throughput for one of my web servers, and I'm going to give you, and we can make intelligent suggestions to actually tell you what your alerts should be, what your alerts should look like, and how they can be configured in sort of a easy, transparent way. And one of the last things I want to show you is another cool aspect of the tool that we think is particularly useful and unique. And so we saw for the first section of this demo, we went from the web layer down. We sort of like handpicked a web server that we wanted to investigate. We handpicked an endpoint that we wanted to investigate in that web server. And we sort of like boiled down into like exactly where that endpoint is spending time. What I want to show you now is actually like how to go from like the shared or the database tier like up the stack. And this is another thing that's particularly useful, especially if you have, for example, a Postgres database that's shared between various applications, and maybe it's under load, or maybe you want to understand where that load comes from. So this is a view of one of our Postgres master databases. And so you can sort of see you have these exact same metrics that you had for the web server, but scoped to an individual database. And I can actually jump down and see every single query that was executed from application land onto this database. And this gives me a really good tool to actually diagnose where expensive queries are coming from. I can jump into an individual one of these and actually dive in and say, hey, here is this problematic Postgres query in the context of the web request that originated it. And being able to actually go from the database layer up the stack like this is particularly useful, especially in cases where your data tier or your share tier is under particular infrastructure, network, or disk pressure. And yeah, this is one of the tools that we found particularly useful. And if you sort of have an environment where you have tons of different databases that are shared between tons of different servers, we give you the tools to actually like isolate them and view health metrics for your master database as distinct from your replica database, and your various shards as distinct from each other. And this is the sort of, we want to give you all the customizability you need to design a map of your infrastructure that actually makes sense, and you can actually like intuit and maps to business cases in a reasonable way. And yeah, if I could jump into the last one of these things. So our tracing service is entirely real time. And so we're actually fielding traces as they come in. We have sort of a sophisticated sampling algorithm that works at various layers that makes sure that you consistently have a view of the most statistically significant selection of traces, and that you consistently are able to know exactly what's happening if you have a problem. If you have a customer on the phone or someone who's emailing you and saying, hey, there's an issue right now with this particular subset of endpoints, you can scope your sort of live view of traces to an individual service or just looking at error traces. And this kind of makes it really easy for you to like track exceptions as they flow through your app and as they flow through the various layers of your database. Yeah, Datadog tracing is sort of a very fast evolving product. We're soon rolling out a more sort of like traditional view for like asynchronous traces that sort of would remind you of the Chrome Inspector timeline view. We're making it easier and easier for you to sort of like just plug this into your app and make sure that your that any touch that needs to happen as far as code changes are concerned are like entirely transparent and happen in a very non-intrusive way. We're actually making it a lot easier for you to search your traces by more facets. Right now, we expose a few sort of like key high-level things. So like you can search your traces by service, by host, or by process. But we want to make it easier for you to like scope these by things that have strong business cases, like customer ID or like availability region, for example. And that's one of the things that we're working on improving and building into the trace product. And as I mentioned earlier, this is one thing that's also very close to landing. We're building out the ability to like have smart suggested monitors for you, such that we can give you sort of like these solid directions on what the baseline level of performance for some of your services are, and how you can like monitor that when it becomes anomalous or it becomes unusual. And all this together sort of makes up our Datadog tracing offering. We're going to have a hands-on session in the afternoon, I think, where you can sort of like play around with it a bit more. Happy to help you guys get set up. And yeah, in the meantime, we're improving fast. Most of our stuff is open source. We welcome you to check us out on GitHub and like ask request integrations, actually like poke through the code and see like how we're actually integrating with your applications. And yeah, we're really easy to get started, so encourage you to try us out. And yeah, happy to take any questions.